All right, so this might be a touch complicated, but I think you guys have the shifting rules down pretty well from Algebra 2. So let's try this example and we'll back it off if we have to. So here's my kind of full-on trig shifting example. I would like to graph f of x is 2 times sine of pi times x plus 1. And I need to note a standing assumption, which is what? Yeah, this is going to be my standing assumption from here on out. When I'm graphing trig functions, I'm going to go ahead and assume that x is in radians. Why? Because Babylonians or something, right? Because the Babylonians just made up degrees. It doesn't mean anything useful. It puts these kind of really big numbers on the x-axis that I don't really necessarily need. So I'm going to go with something a little more intuitive, radians, so I can deal with smaller numbers. Also, it'll hopefully make it more obvious which, let's see, which axis is the angle and which one's the ratio. Okay, I'm with you. Fair point. All right, so first things first, what do you need to graph a function?
A graph.
Okay, so when you look at this thing, oh, you meant an axis.
Axis.
Okay, so here's a set of axes. Down with that, we can start there. What do you see as the most basic thing in F? Like, what's the thing you recognize the picture of? Sine, probably. I'm hoping you look at this and think to yourself, okay, that's my rule. You guys cool with that? Right? That's the rule, the function I know how to graph. I know how to graph sine. Hopefully. If you don't know how to graph sine, you're totally sunk anyway. Right? Okay, now I need to break down which things are happening before, after, during, what. So I want to take a look at my function, and I want to break it into one of these bubble diagrams. So here's your bubble. You're going to start with x, right? So if somebody gives you a number, that's your x. What are you going to do to it first, order of operations wise for x?
Pi. What? No, pi.
Multiply by pi. Good answer. Okay, remember order of operations is this: grouping, exponents, multiplication, and then addition thing, right?
Yeah.
So here, I'm going to look for a grouping symbol. You got a grouping symbol?
Yep.
These parentheses. So you got to go in there, do that stuff first. There's no grouping symbols in there. There's no exponents in there. So I'm left looking at multiplication. So I'm going to do that first, multiply by pi. Now I'm going to be looking at, okay, now I'm living in pi x land. What's my next thing I'm going to do?
2 sin it? Sin it.
I think I'm going to sine it. Okay, so I'm going to apply sine to that thing. Please note, you do not have to think too hard about this because thankfully this is the rule. Right? That's where your picture is going to come from. What do I do after I sine this thing? What's the next step?
Multiply by 2.
I'm going to multiply by 2. And then we're going to
Add 1.
add 1. Okay, so I started at x, I got to pi x, then I did sine to it, so I got sine of pi x, and I multiplied that whole thing by 2. I got 2 sine of pi x, then I added 1 to it, so I got 2 sine of pi x plus 1. That's all good? Pretty cool with the bubble? All right, so the key thing on the bubble diagram is what? Okay, put these two pictures together. Which things happened before the rule?
Pi.
Okay, so here's your before the rule stuff, right? These are modifying x's. So what's that? That's a horizontal, right? I know I'm in the before the rule, so I'm modifying x's, so I'm in horizontal land. Was I adding, flipping sign, or multiplying? Multiplying. Is my number bigger than 1?
Yes.
Pi is in fact bigger than 1. So this is a horizontal compression by a factor of pi. You guys see that? Okay. All right. What's the next thing? It's my sign thing, right? That's my rule itself, so I don't need to worry about that. See that? Rule. Don't worry about that thing. Then my next things are, there's two things, right? This jazz. That's my after the rule stuff, right?
Yeah. You can do 2 things at once.
And I can do 2 things at once. I just got to make sure I get them in the right order. So this one says multiply by 2, right? So what's that? That's a vertical stretch by a factor of 2. So that's one of my things. My other thing is adding 1, which is a vertical. Oh, I don't even really need to write vertical. I should write shift up by 1. You guys with me on that? Okay, so I'm going to pull these apart. Okay, so let me start with my rule picture. So what's sine look like? Wavy thing starts at 0. Okay, so I got to get my points on this a little bit. So here's my wavy thing. Where does this happen? Pi, right? This one happens at pi over 2. This bottom here is at negative pi over 2. And this guy there is at negative pi. You guys all with that? All right, so first things first, I'm going to do my horizontal compression by a factor of pi. So that's this thing, right? You guys all see that? Oh, I should probably also, sorry, one thing. Where's this top and this bottom?
1 and negative 1.
1 and negative 1? I'm going to need those because I'm going to fiddle with the vertical after a bit. So first things first, I'm just compressing. So when I just compress this, what do I get? Like, where do the dots go? When you compress 0?
It stays at 0.
Stays at 0. Okay, so I'm going to have a dot there still.
And the high point now occurs at pi over 4. Right?
So close.
2 pi.
You need to compress by a factor of pi. You guys want another way to think about this?
Yeah.
Okay. The high point's at pi over 2, right? What do I have to put into that to get pi over 2 out?
1/2.
Just 1/2, right? You guys see that? So compressing by a factor of pi means dividing all the numbers by pi.
Oh, so 1/2.
So 1/2 is, let's see, pi over 2 is like 1.65 or something. So I need to go about a third of that. So here's a half. There's 1. Right, these are still on the same axis, but now these are relevant to my blue picture. So 1/2 is going to be the high point. 1's going to be
Below.
the low. How about it? What happens in between them? Yeah, but it's still a little humpy thing, right? It just happened faster. So I got a little humpy thing. Okay, see that? Okay. Where's going to be the next relevant spot?
Half.
At negative a half, good. So at negative a half, what should there be?
Low.
Yeah, that should be the low, right? And where is it going to come back up to 0? At negative 1. You guys see this? So I'm thinking, if I compress by a factor of pi, that's dividing all the things by pi. So this 0 happened at minus pi. So now if I divide everything by pi, it happens at negative 1. Let's go with that. So I just thought, I'm going to smash everything in by a factor of pi. Cool. All right. How does the rest of the blue thing look?
The more compressed version, the one, same height.
Yeah, please note here, right? This is a whole cycle of sine, right? So I could just keep putting whole cycles on here. So it's going to go down and come back up, right? Where are these going to happen? This one's going to happen at 2, and that one's going to happen at
3.
3. Okay, cool. My picture's pretty good today. You guys see this? And then what's going to keep up? What's going to keep happening?
Just
Yeah, it's going to keep on keeping on, right? And then this one's going to go, let's see, -1, and then whole nother cycle. So that's going to be at -2, and here we're at -3. And we're going to keep on keeping on up there. You guys got this? So orange to blue was a compressed by pi. Okay, am I done with my picture? Oh dear God, no.
we forgot.
Okay, so that was the blue thing. Now I need to account for a vertical stretch by a factor of 2 and a shift up by 1. Okay, I'm not going to draw this on the same picture because it'll get too confusing.
Yeah.
And because these steps are a little bit easier. Okay, I really do mean this. The x-axis compression step is probably the hardest one to get right. So be careful with it, take your time, get that one right, because the others aren't too bad. The vertical stretch just works exactly the same way you think it does. So what am I going to get out of a vertical stretch picture? Let's see, I need some cycles. So here's some cycles, right? This happens at 1, 2, 3, -1, -2, -3. What's this going to change? The height, right? I'm stretching by a factor of 2. So the old height was 1 at the tops. What's the new one's height at the tops going to be? 2. What's the bottom going to be? -2. See, that one's not super hard. Right?
Why wouldn't it be 3?
We haven't done the +1 yet.
I haven't done the +1 yet. Is that where you're getting 3? Okay. I haven't done the +1 yet. So between orange to blue, right, I did horizontal compress, right? Then to get from blue to black, what did I do? The vertical stretch. And now what else do I have to do? Just shift up by 1, right? Okay, so the shift up by 1 is pretty easy. You draw the exact same picture you just had. Oh, whoops.
Well, kind of.
I lied. So draw the exact same picture you just had without the x-axis on it. Wow, this picture's getting way worse. Just drop the parts that look bad. Okay, and now I need to figure out where's the top happening now.
3.
That's happening it? Okay, 2 shifted up, 1 is 3. Where's the bottom? -1. How tall is the whole thing?
4.
Yeah, it's still 4, just like it was up here. Okay, see that? So you can keep track a little bit if you think about, okay, how tall was it here? If I just did a vertical shift, it should still be the same height. Or you can just add 1 to all the y values on the picture. So, what's the thing I need to do now?
X-axis.
Yeah, I need to put the x-axis on there. Where's the x-axis happen?
Up
Should
1
be
more.
in between the bottom and
+1.
Yeah, so just count, right? The x-axis should be where y is 0. So I need to go up a unit from -1. So that's got me drawing something like this. You guys see that? Do I know where this happens now?
I think it's a really fun.
This crossing? Do I know where the x-intercepts are on this thing?
Yeah, minus. Oh.
Probably not.
Nah, I lost them. You guys see that? When I changed the x-axis, I lost my intercepts. I had them really nicely labeled up here, right? They were just at the integer values. And then I did something to it and like, oh, I don't really know where that stuff happened.
Is it impossible to find them? Or that was just it? Probably really
It's annoying to find them.
Yeah.
Yeah, we could find it with an inverse sine function, right? Because that's really me setting f equal to 0 and solving.
Yeah.
So I subtract 1, I divide by 2, I take an inverse sine, and then multiply by 1 over pi. That's going to suck. But we could find it. You guys okay with that? So let's not worry about finding those. Realize on some of these you're going to lose some labels. If you want to label some points, that maybe would be good. Okay, right? Because I lost some of my x-axis labels. So can you guys tell me about this point right here, the top? Where's that at? What are the coordinates for that?
One half. Oh.
Good.
Oh no. Sorry.
3.
No, 1/2 3.
Yep, it's 1/2 over, right? That came from this. I didn't change the x-axis after I found the top in this picture. Right? I just changed the y's. So this was 1/2 1 in the blue picture, and then I scaled up. So right here, it's sitting at 1/2 comma 2. And then I shifted the whole thing up 1, so now it's at 1/2 comma 3. See that? Kind of with me on those? What's this point right here? That's 0, comma 1. Right? That's 0, 0 from way back here. But then I did some horizontal compressions and some vertical stretching. Neither of those changed it. And then I shifted it up by 1 unit. Good that. So you can chase around, label a couple of points on this thing just to get a little bit of this down, just so we kind of know that you did the right thing. Cool. Questions on this? Don't worry about trying to find the x-intercepts; they're horrible. Maybe one more of these. Where's this point? Right there. Let's see. Yeah, that's at 1, 1, right? That was way back here to this point after I did some stuff and then shifted it up again. You guys cool with this? You think you can graph these on your own?
No.
You can try at least, right?
Yeah.
So what were our steps?
So